In this lesson, we're going to be looking at isosceles and equilateral triangles. And an isosceles triangle is a triangle where at least two sides are congruent. So the different parts of an isosceles triangle are as follows. The two congruent sides are the legs of the isosceles triangle. The other side that is not congruent is called the base of the isosceles triangle. And then the angle that's formed by the two congruent sides is called the vertex angle. The other two angles are the base angles. And the base angles of an isosceles triangle are always congruent. The isosceles triangle theorem says that in an isosceles triangle, the angles opposite the congruent sides are congruent. The converse of that would indicate that if two angles of a triangle are congruent, then the sides opposite those angles are congruent. An equilateral triangle is a triangle where all three sides are congruent. So, since an isosceles triangle has at least two congruent sides, that would mean that all equilateral triangles are isosceles triangles. So, the converse of that is not always true, though. So just because all equilateral triangles are isosceles, that doesn't mean that all isosceles triangles are equilateral. And all three angles of an equilateral triangle will always be 60, since all three angles must be the same, since all the sides are congruent. And if you divide 180 by 3, you get 60. All right, so we have an isosceles triangle, so angle R and angle Q are the base angles, so they're congruent. So angle R is 2x. So we're going to add up all three of the angles, set it equal to 180. Combine the like terms, subtract 40 from both sides, and then divide both sides by 4, and we get x equals 35. In this example, we also have an isosceles triangle. Since we have two congruent base angles, that means the sides opposite those angles are congruent. So we're going to set those two expressions equal to each other and solve for x by subtracting 2x from both sides. And then we're going to add 6 to both sides, and we'll get x equals 12. Here we have a right triangle, an isosceles right triangle. So the right angle is actually the vertex angle. So angle Z and angle Y are the base angles, so they're congruent. So I should have 3x plus 90 equals 180. Or I could just add 3x and set it equal to 90. Combine the like terms, subtract 90 from both sides, and then divide both sides by 6. X is going to equal 15. Here we have two isosceles triangles. So those vertical angles, angle DKT and angle PKQ, those are vertical angles. So DKT is going to be the same measure as PKQ, so it's going to be 2x. And the angle D is going to be the base angle of that isosceles triangle, so it's going to be the same as angle T, which is 6x plus 6. So we should have 6x plus 6 plus 6x plus 6 plus 2x equals 180. Combine the like terms, set it equal to 180. Subtract 12 from both sides, and then divide both sides by 14. X is going to equal 12. In this example, we need to first find out what the measure of angle GBD is, and we can the easiest way to find that angle is just to subtract 30 from 90, since the two acute angles of a right triangle are complementary. So angle GBD is actually going to be 60, and we have in the figure indicated that angle GBD is congruent to angle BLD. So BLD and BDL are the base angles, so they're both going to be congruent. So they would both be 60. So I would just set 3x equal to 60 to solve for x. Divide both sides by 3. and x equals 20. All right, in this figure, R and S are the base angles, so they're congruent. So we should have 3x plus x equals 180. Combine the like terms and then divide by 5, and we get x equals 36. Here we have an equilateral triangle. All three angles of an equilateral triangle are 60. So we just need to set the 6x equal to 60, solve for x by dividing both sides by 6, and we get x equals 10. Here, since we have an equiangular triangle, it is also an equilateral triangle. So we're going to set the two sides congruent to each other, set them equal to each other, solve for x by adding 5 to both, subtracting 6x from both sides. And since negative 5 equals negative x, that means that positive x equals positive 5. All right, in this example, we're told that the big triangle KLM, is an equilateral triangle. So that would tell us that angle L is 60 degrees, angle LKM is 60 degrees, and angle M is 60 degrees. So I should have 60 plus 90 plus 3x equals 180, or I could just do 60 plus 3x equals 90. Combine the like terms, subtract 150 from both sides, divide both sides by 3, and we get x equals 10. In this figure, we have three congruent equilateral triangles. So all the segments in this figure are going to be congruent, so we just need to set 4x equal to 40. Solve for x by dividing both sides by 4. We get x equals 10. And here, the vertex angle of this isosceles triangle is 60. So that means that the two base angles must be congruent. If the vertex angle is 60, vertex angle of an isosceles triangle, if it is 60, then the two base angles must also be 60. So this is actually an equilateral triangle. So we just set 3x plus 8 equal to 4x minus 4. Solve for x by subtracting 3x from both sides, and then add 4 to both sides, and we get x equals 12. And in this last example, first thing we need to find is the measure of angle HR, HOR is going to be the other base angle in that the triangle on the right. All right, and then since that angle is 60, that would mean that the top angle is 60. Angle ORH is also 60. And so that would make angle MOR congruent to angle HRO. Angle M and angle ROM would both be 60. So we set 4x equal to 60, divide both sides by 4, and x equals 15.